What's up, sixth graders? This is lesson 3, day 4. We are still working on finding equivalent ratios. Now, up until this point, you've done a lot with ratio tables and you've graphed ratios and equivalent ratios. So today you're going to be solving with me problems for different ratios. So what we're going to do first is I'm going to go over the example you see at the top of page 22. So if you don't have your book on page 22, pause this, get your book on page 22 right now, and then restart. And then we're going to go through the problems on page 22 and 23. We're going to have you try them, and then I go over them. Sound like a plan? All right, so first thing I want you to notice while I'm going over this example is you don't need to look in your book because I whited out the answers. Your book has all the answers here. I just whited them out because I'd rather you see how these numbers came about than just look at what your book has written. So don't worry, you don't have to write anything in this section. I want you to just pay attention. But remember, in other parts of the video, I'm going to ask you to pause and do stuff, so make sure you follow those directions. So anyway, let's get started by reading this problem. It says, Jake made hummingbird nectar by mixing 8 cups of water with 2 cups of sugar. So I'm going to underline 8 cups of water with 2 cups of sugar. Allie used 9 cups of water and 3 cups of sugar. So I'm going to underline what she used in a different color. She used 9 cups of water with 3 cups of sugar. And the question says, which recipe is more sugary? Explain why. So, a good strategy whenever you are comparing two different ratios like this, we're comparing Jake's mix in red and Allie's mix in blue. It's a good idea to do 2 ratio tables. So, what I have here is I'll start in red with Jake's recipe here. So remember, he uses 8 cups of water with 2 cups of sugar. So 8 cups of water, 2 cups of sugar. Now, in Allie's recipe, I'm going to switch to blue. She uses 9 cups of water for 3 cups of sugar. Okay, now notice I wrote both ratios on the right side of the tables. The reason I did that is because I'm going to find the rate and put it on the left. All right, so the key to comparing these 2 ratios is to find the rate. So now, notice the relationship in Allie's. To go from 2 cups to 8 cups, you multiply by 4, right? So keep that in mind, because if I want to find the rate, I need to figure out how much water with 1 cup of sugar. So remember, I did times 4, and I get 4. Okay? So this is the rate, 4 to 1. Now I'm going to do the same thing with Allie's. So notice in Allie's to go from 3 to 9, it's not times 4, it's times 3, right? So if I have 1 cup of sugar, I'm going to multiply it by 3 to get 3 cups of water. So this is Allie's rate. Now that we have both of them as rates, we can compare. So now this is the tricky part though. Remember, it says which recipe is more sugary. So in Jake's, it's 4 cups of water for every cup of sugar. In Allie's, it's only 3 cups of water for every cup of sugar. So what one's going to make it more sugary tasting? The one with more water or less water? Well, the correct answer is Allie's recipe. Because think about it, if you have less water for every cup of sugar, you're going to taste more sugar, right? The more water you put in, the less sugary something is. So I'm going to answer this. Which recipe is more sugary? I'm going to answer that first. I'm going to say Allie's recipe. Remember, you do not have to write this because it's in your book, so just watch. Allie's recipe is more sugary. Now remember how it said explain why? Well, I'm just going to say because she uses less water for each cup of sugar. Okay, so that's the example. That's how I used 2 ratio tables to help solve it. So your strategy today is to answer these questions that you're going to be trying on your own. You're going to be doing some ratio tables. All right, so let's go down and we'll read number 17, and then we're going to have you get started. So read it along with me first. And be ready to underline some things, and you could pause the video anytime you need to. So I'm right here with Mrs. Silva. So Mrs. Silva orders 5 pizzas, for every 20 students working on campus cleanup. Now the question says, how many pizzas should she order if 36 students participate? So how many pizzas should she order if 36 students participate? And then, how many pizzas should she order if 48 students participate? So this is a perfect one for a ratio table because they give you the ratio. And then you could use that ratio to answer this question in blue and this question in green. So what I want you to do, you are going to try problem 17 on your own. So you're going to pause the video while you're doing it. So this is a good spot where it says show your work to do a ratio table, which I'm not going to set it up yet. I'll wait till you're done. And then you have to write your answer down here on the solution line. The answer to the green and blue underlined question. All right, so pause the video and I want you to answer 17. As soon as you're done with 17, I want you to restart the video. Go. All right, let's see how you did. You should have number 17 answered if you're watching this part here. So first off, I'm going to set this up with pizzas and students. Now I'm just going to split it into some sections. Now yours might have different numbers than mine, but what it should have is for pizzas, we're talking about 5. So I'm going to start with 1, 2, 3, 4, 5, 6. Maybe you didn't have 1 through 6. Maybe you had different ones. That's okay. But remember, 5 pizzas is 20 students. You must have that correct in your ratio table or you're most likely going to get the problem wrong. Now I'm going to figure out the relationship between pizzas and students here. So I know to go from 5 to 20, the rule is times 4. Right? Because 5 times 4 is 20. So if I multiply the number of pizzas by 4, I'll get the student. So I'm just going to start by doing that. So 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12, 4 times 4 is 16, 6 times 4 is 24. So my table's filled in. Now I want to see if I can answer any of the questions. So it says, let me find it here. How many pizzas should she order if 36 students participate? So mine doesn't go up to 36 yet. And 48. So what I'm going to do is I'm going to add on to my table here. Now I need to figure out if, I'll switch to green for these here, if 36 students participate and if 48 students participate. Now remember, if you multiply the pizzas by 4, you get the number of students. But that also works in reverse. If you divide the students by 4, 16 divided by 4, you'll get the number of pizzas. So what I'm going to do is divide 36 by 4, and I get 9 pizzas. Or you could think 9 times 4 is 36, right? For this one, you could think what times 4 is 48, or just do 48 divided by 4, and you get 12. So these are going to be the answers to my question, which I'm writing on the solution line. So how many pizzas should she order if 36 students participate? So I'm going to write 9 pizzas for 36 students. Put a semicolon and 12 pizzas. I'm going to make it like a ratio for 48 students. Now, if you had that one correct, give yourself a big fat C. All right, so now let's go on. We're not going to do this pair share for now. So we'll do a pair share on the other page. So we'll skip that. So let's go to page 23. All right, so on page 23, this one I'm not going to read for you, but I am going to say as you read it, it's a good idea to do a ratio table and answer your question or questions, just like we did in 17. Now, I am going to give you one hint, that this gal here is giving you a question to think about when you get to the last part of the question. So you're going to want to think about that when you get to what I squiggly underlined. All right, so now, here's your job. Number 18, do it on your own. Pause the video while you're doing it, and as soon as you're done, restart. If you mess up, you're not sure, give it your best, no big deal. You fix it when you watch the video. Go, pause it now. All right, so let's see how you did. So I'm going to start out here. I'm in the mood for a purple pen. So I'm going to start by reading it. It says, David wants to fill his backyard swimming pool. His garden hose delivers 40 gallons in 5 minutes. Now the questions say how many gallons of water will be in the pool after 20 minutes and after 1 hour. Okay, so I'm going to start with a ratio table. So remember, it's just drawing a rectangle, split it in half horizontally, and then put some columns in it. Doesn't matter how many to start with. And it says gallons per minute. So I'm going to put gallons here, per minutes here. And we start with 40 gallons for 5 minutes. So I'm just going to write that here this time. Doesn't matter where you write it, remember. Now, I have to figure out the relationship between minutes and gallons. So did you figure that out? Did you notice that if you multiply the number of minutes by 8, you'll get the number of gallons, because 5 times 8 is 40. All right, so remember that, the times 8. So what if I had 1 minute? Well, what's 1 times 8? It's 8, right? Now, that's not what the question is asking. It is asking us for 20 minutes and 1 hour. So I'm just going to jump to 20 minutes here. Now remember, the rule is times 8. Now 20 times 8, what I do first is I do 2 times 8 is 16, and then add to 0, right? Then it says after 1 hour. Now did you think about this question over here? How many minutes are in an hour? I hope you did, because if you didn't, you probably got this one wrong. An hour has 60 minutes. Now, to figure that one out, we have to multiply 60 times 8. Now, just like I did before, I'm going to do 6 times 8, which is 48. And then I'm just going to add the 0. So my answers are the numbers in red. So I'm going to say 20 minutes for every 160 gallons. And I'm going to say 60 minutes for every 480 gallons. So here's my question. Did you have that right? If you did, give yourself a big fat C, because you know what you're doing. If not, no big deal. You learn from it. Now, this question I want you to think about. It says, how could you use the unit rate to solve the problem? Now, remember, the unit rate is the number with the rate. It's the 8. So the unit rate I'm going to write down right here. The unit rate is 8 gallons. Now, that just means 8 gallons for every minute, right? Now, if you know that, couldn't you just say, well, if it's 8 gallons for every minute, for 20 minutes times 8, for 60 minutes times 8? What if I said for, I don't know, 135 minutes? 135 minutes times, what do you think? Times 8, right? So whatever the minutes are, you multiply it by the unit rate. So unit rates can come in handy. And kind of, did you notice? That's really what we did here when we multiplied by 8. Wow. Okay, so now let's go down to number 19. This is going to be multiple choice. So here's what you're going to do. You are going to pause the video in a second, and you are going to read number 19. And you are going to have to choose A, B, C, and D. Now, this dude over here is saying, what is the relationship between the cost and the number of soccer balls? So he is just saying, look at the cost to the number of soccer balls. Look at the cost to the number of soccer balls. Kind of like we did up in this one. The relationship was you multiply the number of minutes by 8 to get the number of gallons. So what do you do to the number of balls to get the cost? Okay, so now I want you to read number 19. Pause it. Do it. As soon as you're done, don't do down here yet. Just decide if it's A, B, C, or D, and restart the video. Go. All right, so let's see what you did. You should have number 19 done. So number 19 says, Coach McCarthy bought 6 soccer balls for $150. Which table correctly shows equivalent ratios for this cost? So the first thing I'm going to look is see if I can eliminate any answers. Do they all have the ratio 6 soccer balls for $150? And if you look here, all of them have that. So we can't eliminate any answers there. But the next thing I'm going to do, before I start looking at the rest of the tables, is I want to figure out the relationship between the number of balls and the cost. So in other words, 6 times what number is 150? Or 150 divided by what number is 6? Either way, you can think about. So to figure that out, what I'm going to do is I'm going to just divide 150 and 6. So 150 divided by 6, and yes, you could use a calculator, is 25, right? So here's what that means. That means the relationship between 6 and 150 is 6 times 25 is 150. All right, so now if I know that's the relationship, I'm going to start with all of the ones because ones are going to be easier to deal with. So what I'm going to do is multiply each one by 25. So, and see if it works. So let's start with A. 1 times 25, is it 0? No. Can't be A. I don't have to check anything else. B. 1 times 25, is it 25? Yes, it is. So it can be B. Doesn't mean it is. We'll check the other ones. C. 1 times 25, is it 20? Nope. D. 1 times 25, is it 120? No. So guess what? I don't even have to check anymore because I know the answer is B. All right. If you had B and you figured it out, great. You know what you're doing. All right, so now, here is the last thing you are going to do. Let me erase this mess. So we know the answer is B, right? Okay. Now, it says, Kristen chose C as the correct answer. How did she get this answered? Okay, or how did she get this answer? Now, we're going to use this lines. So for this question, we're going to split these lines in half. So this question is going to be on the left. Now the pair share, which we'll do in a second, we'll answer that on the right. So here's what I want you to do. I want you to take a look up here, and I want you to look and see if you can figure out how Kristen might have gotten choice C as her answer. All right? Write down 1 or 2 sentences here. Remember, this is your thinking. Your answer might be totally different from mine, and that's okay. But pause the video, write your answer to that question, restart it when you're done. Go. All right, so now, here's what I'm going to say. Now, I'm not sure what Kristen was thinking. Sometimes people just guess, right? But when I'm looking, I'm thinking maybe was Kristen just counting by 20s? 20, 40, 60, 80, 100, and then just goofed up from 100 to 150? I don't know. I mean, remember, your answer might be totally different than mine, so I'm going to just say Kristen might have counted by 20s for the cost to get her answer. I have no idea what she was thinking. So you don't have to erase your answer if it's different in right mind. You might be right. I might be wrong. We're not Kristen, right? So that's just kind of what I thought. Now, remember, pause the video anytime you need to. Last thing you're going to do is this pair share. So this says, how can you use division to find which table shows equivalent ratios? So what we're asking here, let me erase some of my slop. How can you use division? So what kind of division problem? To show that, for example, these are all equivalent ratios, right? How does division show that? So pause this video, take a second to write your answer, and give it your best shot. Restart it when you're done. Go. All right. So I'm going to show you how you can use division to write your answer here. So let's start with this. Remember up here, I did 100, let me get my pen ready, 150 divided by 6 and I got 25, right? So 150 divided by 6 is 25. 125 divided by 5 is 25. 100 divided by 4 is 25. 75 divided by 3 is 25. 50 divided by 2 is 25. 25 divided by 1 is 25. Because they all equal the same thing, they're equivalent ratios. Now, what would happen if we chose one that was wrong? So we start, remember, 100 divided by 6 is 25. But 100 divided by, or I'm sorry, I said 150 divided by 6 is 25. But 100 divided by 5 is 20. 80 divided by 4 is 20. 60 divided by 3 is 20. 40 divided by 2 is 20. And 20 divided by 1 is 20. Because this one is different, it's not equivalent with the other ones. Okay? I could do that with any one of these. So I can say 150 divided by 6 is 25. But 120 divided by 5 is only 24. Interesting. Now, if you get something different, they're not equivalent ratios. So all I'm going to say, if you divide the cost by the number of balls, you'll get the same answer if the ratios are equivalent. Now, your answer might be different than mine, but you need to have this idea. Somehow, if you divide the cost by the balls, you should have the same answer for each ratio if they're equivalent. If you get a different answer, they're not equivalent. So if you need to pause this one and fix your mistake, that is okay. But guess what? You're done with me. So make sure everything's done. Make sure your mistakes are fixed. And thanks for watching, guys.